Okay, you guys are very smart young people. We are going to do some deduction here. We are going to be Sherlock Holmesian in our filling out of this box of information. I am going to fill out the first part because that's the only thing on here that you don't know or can't figure out once I write the first part. So let us start with that. A system of equations is a group of two or more equations which may or may not share a solution. Everybody cool? All right, so let me tell you what I mean. Is that what I just wrote in red an equation? How do you know? Because it equals something. Since it equals something, does it have a solution? Yes. What is its solution? Great. What is it? Get x by itself. Again, you're telling me how to do it. What is the solution? 2. Is everybody cool? The solution. Is that cool? Excellent. So that equation has a solution. Is that a system of equations? No. Why? Because there's only one of them. If I write a second equation, is that a system of equations? Yes. Do they have a solution? Yes. What is that solution? 2. So do they share that solution? Yes. So what would the solution to that system be? It would be x equals 2. Because 2 plus 3 equals 5 and 2 plus 7 equals 9. Yeah? Is everybody good? All right, now you guys are smart kids. You already know what a linear equation is. What is a linear equation? We've just done 2 units on it. There's 30 brains in here. Somebody can tell me what a linear equation is.
When the numbers go up as a pattern?
Good. That's one of the characteristics of it, certainly. Yes, okay, that works. So all of you are giving me characteristics. Well, 2 of you are, right? A linear equation should be an, not a, Mr. Myers with your bad typing. An equation in which changes to the IV result in a repeated change to the dV. And what does that look like? It looks like this. I make a line, and as I go along here, I go X, then I go Y, and what happens at the next one? Same X, same Y. Right? We all remember that, yeah? Okay. Now, use your Sherlockian powers of deduction to then tell me, you don't need to write it down yet, but tell me, what then must a linear system be? So it's a system, so I must need what? A group of 2 or more what's? Linear equations. Which? may or may not have a solution. Now, you guys are smart kids. For a linear equation, how many variables must I have? 1 or 2, yes? Because I got to have x and y, right? Okay. So then, what must it mean to solve a linear system? We talked up here about solving this. They both were x. So what must be the case if I'm solving a linear system? What about the x and y? Both x and y have to equal the same variable?
No, both equations have to equal.
Right. The x and the y must satisfy all the equations in the system. So what do I mean by that? We're going to show you right over here. X plus y equals 5. What are some values I could put there? 2 and 3, 3 and 2, 1 and 4, 4 and 1, 5 and 0, 0 and 5, -8, +13, a million of them, yeah? Everybody cool? Everybody understands that those are solutions for this, right? Okay. Now, is that a system right now? Why not? Because I don't. No. Because I only have one equation. Now, if I write another equation, do I now have my group? Okay. So now I'm going to try this. Let's go with everybody cool? Okay. Now, is a solution to this equation? 2 and 3. 2 and 3. Agreed? Okay. Now, if this is a solution to the system, then that 2 and 3 would have to work here, wouldn't it? Is 2 minus 4 3? No. So is that a solution to this system? No. Does everybody understand? For it to be a solution, it has to work in both. Is everybody cool? Okay? All right. Now, you are going to learn 3 ways to solve these. 1 is graphing, 2 is elimination, and 3 is substitution. 1 of them works sometimes. 2 of them work all the time. We are going to do the graphing one because we've just done a whole ton of graphing. Okay? We're going to do that one first. Everybody cool? All right. So if we are going to graph, the easiest way to graph is to do slope-intercept. But do you have to? Could you make a table of values? Yeah. Could you put it in point slope? Yeah. You have all the options there. But because we're a little compressed for time, we're going to put it in slope-intercept form. M is what? Slope. B is the y-intercept. So the first thing to do is you convert it into slope-intercept form, no matter what it looks like. Everybody cool? Okay, so if I were to give you this, for example, y plus x equals 4. Could you graph that? What would you do? You'd move the x And you would have y equals negative x plus 4, yes?
Yeah.
And then we would graph it. I would go up to 1, 2, 3, 4. And the slope is negative 1. So I would go out 1, 2, 3, 4, out to negative 4. And there's my line, yes? And I know that every dot on that line will work in that equation, don't I? I know that from grade 9, yes? Everybody cool? All right. So now, let's give you this. Let's go with x plus 2y equals 6. Could you solve that for me? You're going to move the x to get 2y equals negative x plus 6. Then what? Divide by 2. And y is going to equal negative 1/2 x plus 3. Correct? Everyone agree? Everyone cool? Graph it. Where do I put the first dot? 3. And then what? Down 1 and right 1, 2. There's that line. Does everyone agree? What part is confusing for you? Does everybody understand? Now, what is special about that point right there? It's an intersection, which means that point right there is on both lines, isn't it? So if it's on both lines, it's an x and a y that works in both equations, doesn't it? And if an x and a y works in both equations, then it must be the solution to the system. Does everybody get it? Great. Let's see if you really do. There are two lines. One is blue, one is red. How do we graph them? If you wish. What would you do with the blue one if you were going to graph them? Y equals negative x plus 4. Now, that just so happens is the exact one I just did for double practice. How do I graph it? I go where? 1, 2, 3, 4. And the slope is negative 1, right? So it's down 1 over 1, down 1 over 1, down 1 over 1. And it's going to make this line. Does everyone remember how to graph a line? If you can graph a line, you can do this part of this unit. Because now we're going to graph the red one. What do I do? Move the x over. So 2y equals x plus 2. Then what? Y equals 1/2 x plus 1. Graph it. Go to 1. And 1/2 is my slope. Up 1, right 2. And there is where it's going. What is that point right there? It's an intersection. That intersection has an x and a y, doesn't it? And what are those x's and y's? What is the x and a y of that point? 2, 2. Does everyone agree? Okay. If this says that x is 2, this says that y is 2, correct? What letter is that? 2. What letter is that? 2. Is 2 plus 2 4? Yes. So is this a solution for the blue line? Yes. Now, what letter is that? X. X's are 2. So that is negative 2, yes? What letter is that? Y's are 2. What am I doing to that y? Multiplying it by 2. So that's 4, yes? Is negative 2 plus 4 positive 2? Yes. So is this a solution to this system? Yes. Because that point is on both lines. How many solutions can a linear system have? No. In this case, it is 1. Because will those lines ever cross again? No. Because this red line will go on forever right past Tavleen and Brianna's head. And this blue line will go right that way between Aiden and Michael. Will either of them ever stop or turn? No. So they can only cross the ones. Gouda? Great. You guys do the second one. Go. When you think you have an answer, do you have to ask me if it's right, or can you check it? You can check it, so you will know if it is right. Go. When you are done, you can look up on the board and make sure you have done it properly. Is there anybody that couldn't do number 2? Everyone could graph it, right? And everybody knows that wherever the lines touch, that's the solution. Is everybody cool? Everyone is good? Okay. Look at number 3 and tell me what's weird.
1 and 30 whenever you're 2 axes a box.
Yeah. It's easy to graph the blue one, right?
But not the green one.
1, 2, 3. And a slope of 1/2. And it looks like this. Is everyone cool with that one? Okay. Now I'm going to show you something to do with this guy that isn't part of grade 10, but it helps me explain the concept that you are dealing with right now. Is everybody all right with this? Here is what that symbol means. You don't have to write this down, just pay attention. That means what we call absolute value. Okay? Absolute means what? What does absolute mean? So, okay. Does anybody have a different word for it? Perfect. Okay, we're getting warmer.
Like whole intelligence?
Yeah, the whole thing about it. Okay? Now, close your eyes. Pretend your eyes are closed. And I am going to move 3 steps. Okay? Pretend all your eyes are closed. If I move 3 steps to my right, which is your left, what would you say in math is the direction that I have moved? -3. Agreed?
Yes.
Okay. Now I'm going to move 3 steps positive. Everyone agree? Because in math, how many directions are there? 2. Positive and negative. Everyone cool?
Yes.
Okay. In the real world, how many directions are there?
4, 5, 6.
Infinite, right? I can take 3 steps in any direction I want, can't I?
360.
And how, well, I can divide each of those degrees again. How many, what is the same? The positive and negative or the 3? The 3. That is an absolute value. Do you understand? It is, remember when we were talking about the difference between distance and displacement? Distance is an absolute value. So in math, this is telling me that the number in the middle there is a certain distance from 0 with no direction. Does everybody understand? So, there's 0. Here's 7. How far is 7 from 0? 7. So the absolute value of 7 equals 7 because it's 7 steps away from 0. What else is 7 steps away from 0? -7. So the absolute value of -7 is 7 because it's 7 steps from 0. Is everybody cool? Everyone cool? Okay, so now look over here. I've got y and x, right? So y equals the absolute value of x. If I make a table of values, who decides what numbers I can put in for x? You guys do, right? Now, I always tell you to take some negatives and some positives, right? Okay, so let's take -5. So x is going to be -5, agreed? What is the absolute value of -5? 5, because it's 5 steps away from 0. So if x is -5, y is going to be 5. Agreed? Okay. And I always say to use 0 as well, yeah? So how far is 0 from 0? 0. So 0 and 0. And then let's use +5. If x is a +5, how far is it from 0? 5. So look at this graph. It's going to graph something really strange. And I'll use red. I got a point at 0, 0. I got a point at -5, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. +5. So I've got this line. And I've got a point at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That line. What do you notice now? There's 2 places they cross, which means how many solutions does this system have? 2. What are they? -2, -2, and 6, 6. Is everybody cool? Because the absolute value of 6 is 6. Half of 6 plus 3 is 3 plus 3, which is 6. Is everyone good? Isha.
Is absolute value always going to be a positive number?
Yes. But don't worry about that. The only reason I did this was to show you there's other things you can graph that aren't necessarily straight lines, but the rules still apply. Everybody cool?
Isn't the one on the left -2 and 2 or not?
Oh, yeah. Sorry. -2, +2. Sorry. Thanks. Everybody good? All right. Now, don't write down what I'm about to do. Take what I just explained and answer some questions for me. What if I gave you this? How many solutions does that have? 2. Why do you know it's 2? Because it crosses there, even though it's a curve in a line. Right? What if I gave you this one? Come on. Now how many? 4. 1, 2, 3, 4. Everybody cool? What if I gave you this? One, 2, 3, 4. What's the point I'm trying to make? No matter what you graph, whatever the curve, whatever the line, whatever the zigzag, if they cross, every time they cross is what? No, a solution to that system. Okay? What if I gave you this? How many lines did I draw? 4. Do they all go through one point? So there is one system to one solution to how big a system? A 4 equation system. Does everybody understand? Everybody cool? All right. That makes a guy happy. Okay. Listen, I'm going to give you 10 minutes. I want you to do, on this page, 231, I want you to do 3, 4, 6, and 3, 4, and 6. I want you to do 3, 4, and 6 in the next about 6 or 7 minutes. It shouldn't even take that long. Okay? Go. Like I said at the beginning of today, there is another way to do this that is exact. But we are running short on time, so I'm not going to get into it. What I'm going to ask you to do, though, is I want you to do number 7 on your own, which means you're going to need graph paper, right? I have some, but I think the other class used most of it. So I'm going to go photocopy it. Now, may I have that, please, Jake? Please notice I have one giant sheet of graph paper, and on the back, there's a bunch of little graphs. You can take a section of this, like, for example, if you only need, like, your y-intercept is 5 and your x-intercept and your slope is 2/3, then you could just take an area of this and make a little graph and work with it. Everybody with me? Okay. I'm going to go make a few more copies of this. You guys can have a look at that. What do you have to do to all 8 of those equations before you're even ready for graph paper? Put them into y equals mx plus b. So why don't you guys start on that while I go copy you some graph paper? Meanwhile, that is your only homework for tonight, to graph 8 lines. We'll see how many of it gets done. And I will even stop the recording so you guys can talk about how much you don't like me.